So 4.8 is basic counting rule and combinations. Also, permutations. So the goal of this lesson is to be able to determine the number of possible outcomes using the basic counting rule and the combinations rule and the permutations rule. So we often need to determine the number of ways something can happen, and sometimes listing out all the possible outcomes, like we did in the opener with the word joy, is tedious. That's your first blank. So we have the basic counting rule, and the definition is that the total number of ways that several actions can occur equals the product of the individual number of ways for each action. License plates. The license plates of a state consist of 3 letters followed by 3 digits. So how many different license plates are possible? So 3 letters, so there's 26 letters in the alphabet. So that means if we think about a license plate having 3 letters and 3 digits, I imagine in this first spot there are 26 total possible options to insert there. It doesn't say we can't repeat, so in the next spot there are also 26 possible options and 26 for the last spot as well. Digits, 10 digits, so
wouldn't it be 9 because you can't do a 1 and 0 digits?
so 0 through 9 makes 10 digits.
Okay.
Good question. So then we have 26 to the third times 10 to the third, and we calculate that and get a really large number. Good thing, because there's a lot of people that need different license plates. Maddie, what'd you get?
17,566,576,000.
Excellent, thanks. Lots of different license plate options. Next question just says, hey, but what if there aren't any repeats? No letter repeats, no digit repeats. We would do it very similarly, only this time we would multiply. We would be decreasing the number of options for each letter, and similarly with each digit. And we would get how many different license plate options would there be if we don't have repeats? L?
Sorry, I'm writing it down so it makes sense. 1,123,200. It's those numbers.
Did you need an extra 0 on there?
Yeah, I wasn't writing 11.
It's okay. 11 million. You had the right
I had the right
digits, but you were missing a 0. There you go. So a lot of different license plates. Next question is home models and elevation. So Robson Communities, Inc. builds new home communities in several parts of the western United States. In one subdivision, it offers 4 models, the Shalimar, the Palacia, Valencia, and Monterey. Each one of these can occur in 3 different elevations, elevation A, B, or C. How many choices are there for a selection of home, including both model and elevation? Any thoughts on how to do this question? Will? What would you do for determining the number of ways a house can be built? Yep. What numbers?
4 to 3.
Yep, that's it. 4 times 3. Sometimes it just feels too simple. I left all of this space because I also wanted to show you a method for determining in a simple way all of the different possible arrangements of floor plan and elevation. So we're going to just use the first letter of each one, S, and we're going to make a tree diagram. So S, P, V, and M. And this is a super simple one, and these will get more complex even as we get into our unit in the future, where we'll incorporate probabilities, varying probabilities. So like, instead of having a balanced die, like it always says, things that don't have the same equal probability. So on this tree diagram, we have each floor plan has 3 options, A, B, and C. I always have trouble fitting it in to this little space. So we can just list them out this way. Like I said, this is super simple, simplified version, but it works in a more complicated situation. So just for the sake of demonstrating, this is not a bad go-to if you've forgotten which method do I use. I can't remember. Here's a good fallback method. There's 12 possibilities, all of which are listed. All right, and here's our formal definition of factorials. So this could be a new operation for you. You haven't learned a new operation maybe since exponents or radicals. So the factorial just means multiply a number times every preceding number down to 1. With this special definition that 0 factorial is equal to 1. Not necessarily intuitive, so maybe something you need to just commit to memory, that 0 factorial equals what?
1.
Yes, 0 factorial is 1. So the example is just 5 factorial equals 5 times 4 times 3 times 2 times 1, 120. That can be done on your scientific calculator. So if you have a scientific calculator, you just type in the number 5, then go to this menu. It says PRB for probability, and then scroll over to the right until the cursor's under the exclamation point. Press enter, enter again, ta-da, 120.
Do it on
On the graphing calculator, you type in 5, the number, then the math key, which is right under the alpha key. And then if you go over to the probability menu, yours might say PRB. And there's the exclamation point. It's number 4. So you can scroll down to number 4 and hit enter. Or if you just hit the number 4, it saves 1 click. And then you get 120. Oh. 5 PRB, and then you have to scroll over to the exclamation point. Right, so you might, on the graphing calculator, there's a couple extra steps. So you might write that down, those steps, so as you move forward, you can remember how to get there. 5, and then, which is just whatever number, and then math, PRB, and then the number 4 takes you to the exclamation point. All right, our second method is permutations. So a permutation of R objects, the blank is just permutation. A permutation of R objects from a collection of M objects is any ordered arrangement. This is the key word, ordered. Order matters in permutations. It doesn't matter in the next rule, but it matters here. So of R objects of the M objects, the number of possible permutations of R objects that can be formed from a collection of M objects is denoted M, capital P. So these are subscripts. These are smaller and below the capital P, and then R. And we read that as M permute R. Anybody heard of permutations? No? Okay, this is new for all of us. So here's the example. Arrangement of letters. Consider the collection of the objects consisting of the 5 letters A through E. List all possible permutations of 3 letters from this collection of 5 letters. So I did that for you. They're all listed out here. How many of them are there? How many different ways to arrange the letters A through E with sets of 3? So just count them up. 60. Good. So there are 60 possible permutations. That's the answer for B. And then C says, use the basic counting rule. So we use the, hey, just write out all the options rule. And then C is the basic counting rule. So that says, hey, I think about the 3 spots. And how many options are there for that first spot, Mars? How many letters am I choosing from? 5, yeah. A through E. And then for the next spot, I'm not repeating any letters, so there's how many options, Kylie?
4.
Yep. And then Alyssa, for the next one, 5, 4, and 3. Yep, 3 options for that last one. 5 times 4 times 3 is 60. So just kind of see how get the same answer different ways. And then lastly, we have this permutations rule, which says the number of possible permutations of R objects from a collection of M objects is given by the formula. So M is always going to be greater than or equal to R. So we have M permute R is equal to M factorial over M minus R factorial. That's the formula. That's the one to know. So for example, we'll take this letter combination situation, and M is 5, R would be 3, we're selecting 3 of them, and we would do 5 permute 3, which equals 5 factorial over 5 minus 3 factorial, which is 5 factorial over 2 factorial. So we could type that in. Well, I already had that. 5 PRB factorial over 2 factorial, which is 60. Same. Or, and I want you to know the different formulas. Sometimes the questions will reference the formula and not just the answer, so you do need to be able to distinguish between this formula and the one that's about to come. But there's also the option to hit 5 and then just the NPR. N and M are interchangeable in this situation, okay? So NPR and then 3. So that skips the formula, does the formula itself, and just gives you the answer. There's a button for that. And same thing, you probably found it if you have the graphing calculator, it's the same process. If I hit 5, math, go over to the probability menu, and it's this NPR button, so it's the number 2 in this case. And then enter the 3. Mine has subscripts. I have the fancy graphing calculator. Yours might not, and it looks more like the scientific on this graphing calculator screen, but same thing. Example, exacta wagering. A lot of betting and stats. So we have, will you read that one for us, please, Sally?
An exacta wager at a racetrack, if bettor picks the 2 horses that he or she thinks will finish first and the second in a specified order for a race with 12 entrants, determine the number of possible extra wagers.
Okay, thanks. The number of possible exacta wagers, well done. So, order matters. Did you get that? If you're talking about first place, second place, it matters, right? Different prize money. So, first and second is your hint that order matters, and you're going to have to figure out within each question if order matters or not. So then we're gonna do M is 12 and R is 2. So we have 12 permute 2, which looks like 12 factorial over 10 factorial, 12 minus 2. I'll write it out so everyone knows where it came from. And I'm actually going to write out the whole, like utilize the definition of factorial so you can kind of see how this permutation relates to the basic counting rule. So 12 factorial is equal to 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Yeah. Over 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Question?
Couldn't you, since all the numbers on the bottom are canceled out, can cancel out with the top numbers, couldn't you just do the 12 times 11?
Yeah, that's what I'm showing you right now. You're one step ahead. Excellent. So we can cancel out every common factor here. And that's how it boils down to just 12 times 11, which would be the basic counting rule. So sometimes it might be simpler to just use the basic counting rule. Also, you have in your calculator, we could plug it in, right? We could do 12 and then math, probability, and then I'm just going to hit the number 2 for permutation, and then 2, and I get 132. Same. Next one, arranging books on a shelf. So we have 10 books, and we want to see how many ways there are to arrange all 10 books. Any guesses? Just throw out a random guess.
10 times 10?
10 times 10? 100? Okay, anybody else? 10 factorial is a guess. Anybody else? Without using your calculator.
I don't think order matters.
Yeah, so
10
10
times
10.
So order does matter.
Oh,
Well, it says this keyword arrange does kind of clue us into order matters.
Well, if order matters, wouldn't there only be one way?
Well, think about it as the ABC problem. ABC is different than BCA, is different than ACB. So we can just switch books around and it changes everything, right? So order matters. So we know that this is a permutation, right? So we can plug it into this formula here. We know M is 10, and actually, in this case, R is also 10. So we could write this as 10 permute 10, which would be 10 factorial over 10 minus 10 factorial, which is 10 factorial over 0 factorial, which is actually just 10 factorial over 1. So you were correct, Jacob. Which equals what? What is...
6,208,000 lie. 3,628,800.
Did I write that right?
Yes.
Okay, thanks. More than you could possibly fathom. Ways to arrange 10 books on a shelf.
Can you imagine how long it would take to put all of those together? Like, that many ways, how long?
You tell me how long. If it, what do you think it would take? Like, just say it's 1 second per
You take that
arrangement, which is like maybe 1 minute.
How many
Let's say it takes a minute
Yeah, I think it'd take a minute, 'cause it's only
to
10
arrange
bucks.
10 bucks, yeah.
Or
So,
something, but-
Hold on.
It would take, I don't know. 10,000 hours?
10,000 hours, what'd you divide by?
I said it would take 42
1,000 hours?
I had 41.9 after I did
So what do we do? 3628800 divided by 60 minutes in an hour divided by 60,
Seconds.
no, not 60 seconds, hours in a day, 24, right? And then, so 2,520? 24 hours in a day.
so 2,520 days, and that's almost 7 years.
It's a long time. So,
How much they're worth?
extra credit, if anyone wants to take it on. Just,
7 years.
just take a video.
Credit.
It's like one of those videos where
Come back to me in 7 years and show me your proof.
they would get a picture of the kid every day, like through their life, like us doing the books.
Oh my gosh.
That'd be funny. You know
Yep.
what I mean?
Mm-hmm. He'd be 7 years from now. He'd be like 25, 24.
First in the year.
Wild.
Say 7 years later, I'm here.
That's if that's all you did for every minute of the day. All right, combinations.
Oh yeah, it takes even longer because you have to sleep to eat.
Yeah, you couldn't sleep.
And you have to work most likely.
So we have arrangement of letters. In this case, order doesn't matter. So we have the 3 letters, but ABC is the same as all of the 6 options that are listed here. So we're only counting all of this as 1. So basically divide by 6. 60 divided by 6, there's 10 different combinations for 5, choose 3. And the note is just what I just said, that if you look at the table and by special permutations rule, there are 3 factorial or 6 permutations of these 3 letters, A, B, and C. And because any such permutation is accounted for in this way, there must be 3 factorial times as many, so there's 6 times as many permutations as combinations, which is what brings us to this new formula, which is exactly the same as the permutation one, but we divide out the R factorial. So we divide out the accounting for all the different ways to arrange each different group of size R. So, for example, there's CD Club introductory offer to recruit new members a compact disc. CD Club advertises a special introductory offer. A new member agrees to buy 1 CD at a regular price and receives any 4 CDs of his or her choice from a collection of 69 CDs. How many possibilities does a new member have for the selection of 4 free CDs? This was the thing. I was one of the members, and I always thought I would win the deal. But there was a catch. Then they would just send you the monthly CD and charge you, and then you would just be charged all this extra money, and it never worked out the way I had planned, which was just get the 14 free CDs and then cancel. But you forget to cancel. So here it is. So in this case, M is 69. Options for CDs, R is 4, and we're doing 69, choose 4. So that would just be 69 factorial over 4 factorial, and then 69 minus 4, which is 65 factorial. So when you type this in your calculator, just be careful that if you do the 69 factorial divided by, if you the denominator needs to go in parentheses. So that'd be 4 factorial 65 factorial, which gives me 864,501. Does anybody have a faster way to do this? Yeah, that's the other way. So you would first put the 69 and then go to the math button, probability, and hit the NCR. And then hit the 5. 69, choose 5. When I said 5, I meant 4. There you go. Look at the difference that makes. 800, same answer, but faster, as long as you put the right numbers in. Last example, sampling students, an economics professor. Will you read that one for us, please? I'll take a volunteer. Who wants a volunteer to read the last?
I volunteered.
Okay, I saw Jacob's hand first. Go ahead, Jacob.
Sampling students. An economics professor is using a new method to teach a junior level course with an enrollment of 42 students. The professor wants to conduct in-depth interviews with the students to get feedback on the new teaching method, but does not want to interview all 42 of them. The professor decides to interview a sample of 5 students from the class. How many different samples are possible?
Thank you.
Anyway, read anyways.
What does M equal, Samantha?
What? Sorry, I was drawing squidward.
Thanks, O.
Yeah, thanks, oh,
Well, what's R, Samantha?
5.
Excellent. Does order matter?
Nope.
Doesn't matter. It's just a random sample. So we're going to do 42, choose 5. One little trick, if you don't want to go back to the math menu, is just to go up and press enter, and then just change the values. So this time I have 42, choose 5. Or just start from scratch and go back to the math menu. So it's MCR, or in the calculator it's NCR, but they're interchangeable. M and N are interchangeable in this case.
I was gonna say, because with my calculator, it has NPR and NCR.
Mm-hmm. Yep. The N and the M are interchangeable. Alyssa, what did you get?
Oh, my calculator doesn't do that. Like, I don't have an option to do any of that, so.
Oh, okay. Well, what about even the factorial? I'll help you find it.
Okay.
Oh,
850,668.
excellent. That's how many different possible samples there are. So, as always, if you have any questions, let me know. Get started on your assignment.